Hey there, everyone. My name is Ryan Schul. Welcome to my channel. This is now called Analytics in Practice. I had previously called this channel, Straight Data Science. It was very focused on data science at the beginning, but over time, it's really evolved quite a bit. And it's more, I feel like it's much bigger than just data science. Data science is one little tiny nugget in the world. Analytics is huge, right? That can be all kinds of different things. It doesn't have to be data science, right? So I think as this channel has grown and matured over the course of the past year, so I think it was good to rename it and to start looking at other types of scenarios and start solving other real world actionable problems because I was kind of running out of things to say about data science. I've got all kinds of videos that cover all kinds of different topics in the data science realm, but I want to keep going with this, so I'm going to expand my perspective and the perspective of the channel. So in the narrative today, I want to talk about entity resolution, and we're going to use both fuzzy matching and embeddings. I'm going to use a combination of these things. So what even is this? What is entity resolution? Basically, in the real world, you see a lot of messy records that don't really match if you're trying to do VLOOKUPs or joins in a SQL database, and the records are off just a little bit, whether it's a person, a company, a product, an address, you can't even find what you're looking for, right? Because maybe nothing will match what you were searching for. When you use fuzzy matching, we can look at probabilities of a match, right? So if something is maybe 98, 99% compatible or similar, then we can find the record pretty easily. Somebody could have fat fingered a key. We could have a data quality issue or something like that, right? So if we are looking for records that say Acme Inc., but some records, one or two or more, say Acme Incorporated, but we know these are the same thing, and Acme UK Limited, if these are all the same thing, we want to be aware of that. We want to find these records. We don't want to say, okay, I'm looking for Acme Inc., and this record that's Acme Incorporated, but that's totally different. That's totally different, guys. We don't want that. If that's what we want, we have to use fuzzy matching, right, to pull back these records. If some records, in another country, in some offshore enterprise or Acme UK Limited, but this is really rolls up to the same parent company, we want to know about that, right? We don't want to say, oh, these guys don't count over here, right? If the revenue is supposed to flow up to the parent or the business somehow is integrated with the parent, we want to know about that, right? So it basically improves joins, improves any kind of CRM, billing, support, right? If these are somewhat not equal, but substantially similar, that's what we want. We want to grab these records, clean them up, consolidate them, and improve the overall accuracy of the data and the accuracy of the models, right? The potential for the model to make predictions into the future. But if we have really messy, not messy, I'm sorry, I'm thinking fuzzy. If we have really messy data and we can't do these joins or we can't fetch the data the correct way, then we put it into the model. The model is not going to learn as efficiently as it could if it had correct, clean data, okay? So fuzzy matching really comes into play here by editing the distance or the token sort ratio. There's a couple different ways to do this. This is one of the most popular, the Jardo-Winkler, and it handles typos, transpositions of letters and names, abbreviations, John Smith versus John Smith, right? If this versus, or IBM versus International Business Machines, right? If we know fundamentally this is the same thing, we want to take this and clean it up, right? And match this data together. If we know that these two people are the same, but somebody left off the H over here, that could have an impact on their business, right? We can't find this guy, John Smith, he doesn't exist. But with fuzzy matching, we can find him very easily, right? And embeddings are basically sentence or character transformations. So we capture semantics in words. So NYU Langone Health is basically New York University Medical Center. Now, if these two are the same, so embeddings will notify this this for us. They will notify us of this, whatever I'm trying to say here, can't think, and handles cross-language translations and different contexts. So Apple, the company, versus apple the fruit, these are really two different things, right? Even if the spelling is the same, and this lowercase apple really should be lowercase a really should be lower, and this uppercase a should be upper. We know that these are two totally different things, right? And embeddings will help us to understand this. But if you just send that into a computer model, the model is not going to know the difference between apple and apple, right? So we have to do some data cleanup or preparation of the data before we submit that to the model. So I have some data here. I looked for some examples online. I didn't find anything very interesting, so I just created my own. I do that a lot. I create synthetic data just to illustrate the point of how this is done. So we have our data frame, and this is basically just IDs, account names, okay, Acme Capital LLC, Blue Harbor Advisors, Everest Partners, Rainier Lending, and then we have Acme Capital LLC with the periods in between the LL and the C. Blue Harbor Advisor, right over here it's Blue Harbor Advisors. Now, if these are fundamentally the same, I want to know about it. If they're really different, I want to know about that too. But I can't just take all of this and just jam that into a model and expect the model to clean up the data and to make accurate predictions on the data, right? That's not going to happen. We have to clean the data first, then feed it into the model. If we don't do that, then the output from the model is going to be basically pretty much useless. So we're going to go ahead and do fuzzy matching right here. We are going to get the similarity of the name and similarity of email address, okay, from the fuzzy score. So we have over here, canned is the data frame, okay? So these are all the candidates that we're feeding in, and we are looking for the scores from this fuzzy matching, right? So we're looking at the I score and the J score. So this helps us to loop through all the elements in the whole data set that we have, right? And again, the data basically comes from over here. Let me see, am I actually printing this? I don't think so. Let's just print it down here. Okay, let me add one small print statement right here. This is good. Just to make that, I think, a little bit easier to interpret. I think this is going to help things, and I'll put one more down here. I think this is going to be a little bit better. Okay, let me put this into a new cell too. Okay, so let me just do this on the fly. This should be fine. Okay, insert a new cell here, and I think we are good to go. Okay, so just to make it a little bit more readable, okay, I worked on this code for a little while, and sometimes I get down into the weeds on these things and then just run it and go with it, right? But let me see. Oh, wait, that's too big. Go ahead. This is small anyways. I don't even think we need to do just the head. There's only like 10 records in here anyways. You know what? I'm not even going to do that. I'll just leave it as is. There's only 10 records. Okay, so run it. Okay, so we have the IDs, the name, address, city, state. And again, we're trying to look for matches, things like this right here with that. Those should match up. Okay, I can guarantee that's the same thing. Blue Harbor Advisors is going to be the same thing as Blue Harbor Advisor. Right, and I can tell that because they have the same address, but even the address is slightly different here, right? So they have an abbreviated boulevard, right? So if we tried to match these two records using a conventional system, either SQL or Excel or Python, these will not match. But I can tell that it's the same company, right? The zip code is the same, okay? This has an abbreviated boulevard. This has boulevards spelled out. Somebody probably forgot the S. Is probably a bunch of people here, unless this is just a sole proprietorship and one person works there and it's just an advisor. Maybe that's an advisor. It's probably advisors. It's probably plural. And over here we have the same email address, right? And the same EIN. So we know these numbers are the same, right? But if we try to join them using a conventional method, it's just not going to work, right? It's going to get messed up because it can't make these connections. It can't figure out what needs to be done. So we're going to do some cleaning on the data, Control Enter to run this. Okay, once the data is cleaned up and we're looking for the fuzziness of the score, that's what these records are here for, and the embeddings occur here. So remember, we're doing two things. We're doing fuzzy matching and embedding. The fuzzy matching to look for records that are substantially similar but slightly different, and the embedding is more like the words used in a specific context, right? So Apple, the company, is going to have a capital A, PPLE. Apple, the fruit, is going to have a small a, PPLE. These are fundamentally different and distinct, and we want to keep them separate and distinct, not because the spelling is exactly the same, because the context of Apple, the company, and Apple, the fruit, are completely different entities, right? Completely different things. So we have the fuzzy matching done. We have the embeddings done, right? And again, we look at all the I's and all the J's. So traditionally, I don't know the exact history of this, but it's been done like this in computer science for probably at least 40 years, maybe more. The I and the J is going to give us the opportunity to do two loops, so we can capture everything in the entire universe here that we're working with. So the first I is going to loop through all of the rows, and the second loop is going to be the columns. That's why we have an I and a J. So we're going through every single element in this whole universe, right? All the I's are going to be all the rows, all the J's are all the columns, and we can get everything that exists in our universe as it stands right now today. So we can add a threshold. So anything that has a match above 70%, yes, this is a good match. This is what we want to keep. If the match is much lower, like 20 or 30%, that's probably just a totally different record, and that shouldn't be matched anyways, right? So we're setting a certain threshold and telling the fuzzy match and the embedding that the scores should be higher than 0.7, and this is probably a very high probability that this is a match, right? If the scores are very low, like 20 or 30%, then that's not a match. It's something totally different. And again, if you look closely, you can see right here, this is probably about 99% matching with this. This is probably about 90% matching with this, okay? And this right here, Acme Capital Group will have very low match with that. That's going to be maybe 2, maybe 5%. And this right here is going to have almost no match with that, probably very low 2 to 5% match, right? So anything greater than 70, we were saying that is a true match. That's what we want to keep. That's what we want to focus on. Anything less, and it's not a match. It's just different records. That's all that is. Okay, so we have the final data frame here, and I've assigned clusters to these two. So we can say, okay, these names mostly match. They're being cleaned up, and these things look good. Okay, and these are going to be clustered into just one different group, right? So here we have Blue Harbor Advisor, Blue Harbor Advisors. Again, the email is the same. The EIN is the same. These are going into the same group because or the same cluster, right? Because they're mostly the same. You have Rainier Lending, same EIN, same email address, right? These are same bank, last 4 numbers. And this actually goes into different clusters. So this is actually being assigned to a different cluster. That might be a mistake. I'm gonna have to look at that, because just looking at it visually, I would say it probably goes to the same cluster, like these guys over here, right? They're both going to cluster 1, and Acme Capital are both going to cluster 0. But you know what? Let me look into that. Let me try to figure that out. All right. So it looks like the pairing was done on the first, I think, first 8 letters. I just looked into code a little bit. 1, 2, 3, 4, 3, 4, 5, 6, 7, 8, and that is 8 over there. So I think basically 1, 2, 3. And use the keyboard. 1, 2, 4, 5, 6, 7, 8. Yeah. So the code was, it's doing what it's basically supposed to do. This was a weird one. So it's looking at the first 8 letters here. So there's Rainier with a space. And then if it looks at the first 8 here, 1, 2, 3, 4, 5, 6, 7, 8, it was thinking, okay, Rainier with a space is not similar to Rainier space L. So it went into a different cluster. Okay. So that's a little bit unusual. I added in a little more testing and robustness just to make these searches that the code has to do a little bit more refined, and maybe you could call it bulletproof. Okay, so it's just doing more of a holistic check on all the similarities, all of the fuzzy matching, all of the embeddings, and all of this stuff more comprehensively and more like big picture. That's the way it really should be done. So you can see now these are all in the same cluster, right? Cluster 1, these are cluster 0 over here. Here's cluster 2, cluster 3. These are together now. That's the way it should be. And then this one is in cluster 8 because it's different from the peer group. Okay. So I think we fixed that. We have the scores down here. The EIN matches exactly right if you look at these EINs. So that is very helpful too. So you know this is the same account. You know this is the same account. You know this is the same. These EINs match up perfectly. The emails match up perfectly, right? Same email. So those are good. And we have the bank, last four of the bank account statement. So those match up perfectly. So, using these techniques, we can make these assumptions that these two entities are the same. Okay, there was a spelling mistake, but they're really the same because the EINs are the same, the email contact information is the same, and the bank last four ID account number, whatever it's called, account number, I guess, is the same, right? And we're still using all the I's and the J's, so we can go through every single row and every single column and do these matches, right? The fuzzy matching and the embedding, and come to the conclusion that okay, these are substantially similar. They should be in the same bucket, and we've done our matching. Okay, so the data is in a much better state right now. So basically, the resolved table, we're looking at groups of records from different source systems that have the same real world entity. These should be cleaned up, but they're not cleaned up. I've worked on Wall Street for a little over 20 years, and you see this everywhere. It's systemic. You can't get away from it. It's just absolutely everywhere. There's just dirty data all over the place, right? Sitting in Excel files on people's desktops and network drives and databases and all this, right? And try to join it together or merge it together, and ultimately maybe even feed it into a machine learning algorithm. We're not even doing that. We're just trying to clean up the data at this point. It's pretty messy. But again, we need good, clean data to put into that algo, or it's garbage in and garbage out, right? So we can't make accurate predictions if we're feeding it a bunch of trash. It's just not going to work. So we see the clusters here. These clusters look like they're in good shape now. We're looking at the pairwise matching. That looks fine. All these EINs match up. The emails match up, and the last four digits of the bank account number match up. And we use the I and J looping, right, to go through all the rows, to go through all the columns, and to do all these comparisons, right? So I think things look to be in good shape now. How can you add this to a workflow? Now you would feed in your own actual data. I don't have your data. Clearly, your data is yours. Mine is mine. I just made this up. This is just a hypothetical example. But you would take this technique and run that over your own data set, right, to do these analyses and then clean up the data, right? So Rainier Limited, or whatever that thing was called, what is it? Rainier Lending and Rainier Lending should be the same, and you should fix that in your source system, okay? So they do match up. So this should be probably an exercise that you might do, just guessing here. Really depends on a few different factors, but maybe once a month, once every couple of weeks, maybe once every 2 months, something like that. But you would want to pull the data from different source systems, do this kind of comparison matching, the fuzzy matching and the embeddings, clean it up, right, and make updates in the data itself, or you can do an upsert. So an upsert is basically a combination of an update and an insert. When you upsert records, if the record is actually different, it's going to make an insert of that record, right? It's going to insert into the database. If the record is dirty and it already exists, but it doesn't exist with the right spelling, that would be updated. So the upsert makes inserts if it doesn't exist. If it's close but wrong, it makes an update. Okay, so it's an upsert. So that is another kind of exercise that you'd want to consider. So fuzzy matching is basically comparing strings when you don't have exact matches. Instead of asking, are these strings identical? Fuzzy matching really says, how similar are the strings? Are they 80, 90%, 95% similar? Are they at least 70% similar? Then we want to know about that. If it's less than 70%, I can pretty much guarantee you it's a different string, right? It's a different company, it's a different name, it's a different address, or whatever. Things are different under 70%, right? So that's the threshold there. What are embeddings? Basically a vector representation of data. So we'll take words, sentences, names, transactions, customer IDs, not really ID, more like customer name, and try to understand the context, right, that the word exists in, and do we have to make an update to this, right? So this and this, I don't have the LLC over here, are substantially the same, right? And we know what context, that's the name of a company, right? And we convert all the words into numbers, right? So I've talked about this in several of my videos. When you do embeddings, you're basically taking words that the computer doesn't understand. It doesn't understand what is a bank, what is a person's name, what is a street address. The computer has no idea what these things are. But when you convert that into a bunch of numbers, which is a vector representation of the string, then the computer can understand that, okay? So that's why we have to vectorize it or create these embeddings. So fuzzy matching really works well at a character or word level. The text types, punctuation, or typos, punctuation, and it knows that these two things right here are pretty close. It knows that these two things right here are pretty close. These are just different typos, right? So fuzzy matching will pick up on those pretty easily. Embeddings works more at a semantic or meaning level. What is the context of this thing? What does it actually mean? It detects conceptual similarities, like Bank of America versus B of A. This is pretty close. I don't think fuzzy match is going to get greater than 70% for this. This looks very different, but the embedding is going to pick up on that and say, this is very close. These two belong together, right? And I think fuzzy matching would pick this up, but it might be a mistake. Like Acme, the company, and acne, if you have oil on your skin or pimple or something, these are really different things, right? So the fuzzy matching will probably say these are going to be very close, very similar, probably 85 to 90% similarity. But the word embedding is going to say these are really different things. The context of these two words are really totally different. Like Acme, the company, and acne, if you have a pimple, two totally different things, right? So fuzzy matching would get tripped up, but the embedding would figure it out. So that's why we use both. We combine both of these, and we have a pretty powerful solution to get the data clustered correctly together and aligned and cleaned up. And then the next step from here would probably do an upsert into the database. Again, insert if the record doesn't exist. If it exists, update it with the correct spelling of the word. So that is it, guys. That's pretty much it. I think I covered all the stuff I wanted to in this one. Entity resolution using fuzzy matching and embeddings. And that's pretty much it, guys. I think we nailed it. I think we accomplished this mission. So that's all I want to show you with this. So I'm going to stop the video here, and I'm going to post that in just a little bit, and I'll share that with you later today, and I'll share all the code. I'll download the source code right now so you have all the code. You can copy and paste this in your own Jupyter Notebook environment and run it right out of the box here. It will run as is, I can guarantee, as long as you have your libraries installed. These are the libraries that I'm using. If you have any error, just do pip install for these libraries and you'll be back in business. Okay, that's it, guys. Thanks for your time today. Really appreciate it, and I'll see you soon when I post the next video. Goodbye.